Good morning, everybody. Welcome to EPA headquarters, Region 2 headquarters. My name is Rob Pirani. I'm the program director for the New York, New Jersey Harbor and Estuary Program. And we're really, before we get started, first of all, of course, thanking EPA, our host for the meeting. And we're going to hear in a minute from Joe Matthews. But always great, to be here at EPA. And of course, and of course, many the four partner groups that you see represented here, and that we'll hear from in just a second. This has been a tremendous exercise, really testing sort of the boundaries of what citizen science can be, both from a public education, science, and a regulatory perspective. And I think that's really the goal for today, is to kind of listen to what happened over the course of the last year from the perspective of all the different parties that took part in it. And to have, we're going to conclude with really an open discussion about what works, what doesn't, and, how we can move forward as an estuary program and as, a community in making citizen science work here in New York and New Jersey. Let me also just, obviously I don't want to take a lot of time and recognize all the individuals involved, but I do want to recognize Gabriela Munoz, who has really been sort of the glue behind the project and today's event, and thank her for all her hard work, continuing hard work on the project. So with that, let me introduce Joan Matthews. Joan is the director of the Clean Water Division for US EPA Region 2, where she serves not just New York and New Jersey, but also the Caribbean, Puerto Rico, and the US Virgin Islands. She leads a team of engineers and scientists on a number of clean water related issues. I know personally she's so committed to making clean water work here in New York and New Jersey, and has really stood up for clean water when others haven't. So with that introduction, let me turn it over to Joan.
Thanks, Rob. Just put that down there. Great. Thank you for that. Go, hang on to this. Okay. So yes, let me echo Rob's sentiments in terms of good morning, everybody. We've been waiting for this event for a while, and we've been so excited about it. So, and maybe the energy may not be as high right now, but it's going to be once we start hearing these presentations. So, thank you so much for coming here and for sharing your wonderful, wonderful work. We all learn from each other. So, thank you so much for that. And so, if you look around, the workshop is really well attended, and it's really a testament to you and to your commitment to citizen science. And I should tell you that Judith Enck really wanted to come up. So she wanted me to say hello to you all, and that she wants a full report on the great work that is being discussed here today. So we will get that to her. And it's very exciting for us to be here and to hear from all of you for so many reasons. It's an opportunity to hear from our citizen science peers on the important work they are doing and how they are making it all happen. Great to learn from each other. It's a chance for us to discuss the success of community-based science, and specifically about water. And it's a critical opportunity for us to discuss the challenges and making citizen science efforts rewarding, meaningful, and effective. As our presenters will highlight, and the panel that follows, citizen science plays a key role in our understanding of our local and regional environments. You are there in communities around our region where the need for data and advocacy is greatest. The work of citizen science doesn't just help academic institutions and agencies. It helps your communities directly. You act as the eyes and ears of local environmental conditions, and then you tell us about it, and then we can do something about it. Citizen science promotes education and environmental stewardship through participation in field activities such as collecting environmental samples of or documenting critical habitats. It focuses on answering both simple and complex environmental questions. The key to the success of citizen science projects lies in the effective and open communication and coordination among all partners, as well as your continued commitment and passion for your communities. You make it work. I'm pleased that Pat Sheridan, our citizen science coordinator, is here. Pat, raise your hand. There she is. If you don't know her yet, please reach out to her sometime during this event and say hi and get to know her a little bit more. As we get started this morning, I'd also like to thank Gabriela Munoz, as Rob did. Gabriela really worked very hard to put this together, and we're very appreciative of that. I'd like to thank Rob also of the New Jersey Harbor and Estuary Program, both Gabriela and Rob. And Alyssa Arkaya in the back, raise your hand, Alyssa, in the Clean Water Division, for their work in making today happen. So thanks to forums like today, in which we are learning and sharing with our presenters, this critical effort can grow and make even more contributions to our community. So I want this to fall. Here you go.
Okay, good morning, everybody. Can you hear me? No? Okay, let me try. I'll just hold it. Is it better? Okay, good. So good morning, and thank you all for coming. I mean, we're very pleased to have a large audience, and we have more people joining via webinar. And I also wanted to thank Kate for taking care of the webinar and the technical details and the technical staff at EPA here that are helping us with the settings. So before starting, I wanted to go over a few logistics. First of all, I wanted to let you know that we are recording this webinar and we will be posting it so you will be able to view it later and share it with others that couldn't be here today. The bathrooms, if you haven't seen them already, are right through these doors. And just one note, the ladies' restroom, the handle is not working properly, so you have to really push it very hard. And same thing in the way out. So don't panic, you're not locked, just you have to be strong. I've had the pleasure to work for the past year with 4 very dedicated teams of citizen scientists. So I'm really excited to hear about all the great work that they've been doing today. And so I want to thank them all. And actually, I'm going to invite them to come to the table. We're going to hear them present. Well, you can come later, but so basically I want to thank the Sparkle Creek Watershed Alliance, Friends of the Bonsall Preserve, and Montclair State University, New York, New Jersey Baykeeper, Bronx River Alliance, and Rocking the Boat, who are form the different teams that have been conducting this project for the past year. So for those of you that are not familiar with the project, this all started when the New York, New Jersey Harbor and Estuary Program, together with the New England Interstate Watershed Water Pollution Control Commission, received funding from EPA to implement this citizen science. And the basic idea of it was to provide the tools that citizen scientists needed to generate credible data and good quality data that could be used for different purposes. And also to engage community residents in taking care of their local streams by engaging them in citizen science. And this has been a truly collaborative effort, and this couldn't have been possible without the great effort and resources that many partners contributed. EPA, in addition to funding, really provided many resources, equipment, supplies, access to their lab, technical support on all the different aspects of the grant, training, preparing many documents that will be useful in the future, including a quality assurance project plan and standard operating procedures and many other things that are becoming resources for anybody that wants to start a citizen science program. Then the two states, New Jersey DEP and New York State DEC, collaborated in shaping the program and making it happen. Together with the Interstate Environmental Commission as well, they all provided very useful suggestions and background information on other similar efforts. And New Jersey teams really did a great job in learning all the different to learn to use the equipment, learn the different procedures, going out and in the field, collecting data, analyzing it, and managing it, and then also staying on top of all the grant requirements. So they've done an amazing job. And the Harbor Nursery program and all the partners that have been involved, we have learned many valuable lessons that we will be taking into account in the future, and we'll talk more about that later. And also today, we're hoping to learn more from other citizen scientists in the room, and we'll also be reaching out to you for additional input. So so I don't want to take any more time, so I want to turn now to the presentations. So we're going to first hear from the four groups, so I will ask you to please hold the questions until the end when we open the floor for questions. So if you want to step up, we'll start hearing from Larry Vail from the Sparkle Creek Watershed Alliance. They've been monitoring in the Sparkle Creek in Orange County.
Rockland County.
Sorry.
They're close.
I'm sorry.
I have maybe 35 handouts. I can just hand them out and I guess take every third one or something like that.
Okay, and we can share this with you later. Oh, I forgot to mention we have a sign-up sheet in the back table. So if you haven't, you can just check next to your name. If you're not there, please add your contact information so we can send you follow-up materials.
Great. Okay, how do I do this? Let's see. Put it. We'll do a test in a second. I'm not too shy about speaking. Can people hear that? Somehow? I don't hear it on the. Oh. Pointer. Okay. Very good. Okay. I'm here from the Sparkle Creek Watershed Alliance, and we're in Rockland County. And I'm going to move pretty quickly through this because I really push my time limits with the number of slides. So, like Gabrielle says, I think there's time for questions later. I want to acknowledge all of the great partners that we had on this. This was our first time in doing a grant like this, and everybody was extremely helpful. Riverkeeper was not directly involved with this, but as you'll see later, they've been our partner in a number of testing projects we've had over the years, and they were also our fiscal agent for this grant. So I really appreciate their help as well. And this, by the way, is an aerial of the north portion of the Piermont Marsh. And this is the Sparkle as it comes out into the Hudson River. Here's our agenda. Then I want to kind of orient you. I think it's important to know where we're talking about. So the Sparkle watershed straddles the line. There's the New Jersey state line. And this is the Hudson River looking north. We're on the west side of the Hudson River. This is all the Palisades along here. So the Sparkle is one of the only significant breaks in the Palisades. And I think the Sparkle has a couple of interesting aspects. One, like I said before, it does empty out into the Piermont Marsh, which is one of 27 national estuarine research reserve locations in the United States. So, and one of 3 on the Hudson River. So this is a significant ecological area, and that is right here. The Piermont Marsh is 2 or maybe with the underwater part, maybe 400 acres. The other thing is that except maybe we don't have too much agriculture, but we've got highland areas that are in state parks that are very pristine. We've got low places, we've got strip malls, we've got residential, and then of course we have this very interesting ecological aspect in the where it comes out into the Hudson. Our group, the Sparkill Creek Watershed Alliance, is an all-volunteer group. So we're not an agency. We're not. We just meet once a month, and in its current iteration, we've met for the last 4 years. We have a lot of great things that we've already done. I've listed some things here. Some of these are aspirational. Some of them we've already started on. But I want to take this chance to thank Rutgers University. Dr. Brent Turin was a partner with us from the very first day we started even talking about the grant application. And his 2 students, Anna Gravina and Roddy Jordy, shown. Oh, I'm sorry. Well, that's. I don't know how I got all the way to the end. Okay, there went 30 seconds of my time. That Anna and Roddy are in these bottom 2 pictures here, and they were great. And so they came down and actually did the testing in the EPA lab. Well, that's interesting. Part of it's on your handouts, but I think the important part is here. I didn't realize that wasn't going to show up. We have some overall goals in this project, and Riverkeeper has helped us by identifying the fact that we have an Enterococcus, I think, problem in the Sparkill Creek, as there are in many other parts of the watershed. And then we've done testing with them for several years, and now we're getting more proficiency at that testing. We're getting data that basically we're getting data we can use. And those are the 2 parts of the goals for our project here. We want to test, and we want to get data that people believe in. And of course, we want to progress in our understanding of this problem. Now, this is where we started before we did any testing. This is a map of all the Riverkeeper locations. So here's the main stem of the Sparkill, and the watershed is in the brown border. And these red dots are where we tested 16 different sites, basically once a month in the warmer months of the year for the last 4 years. We basically found that that there was very high counts for Enterococcus everywhere in the watershed. Some places not so high, some places not so high when there wasn't any rain, but everywhere high. In fact, off the scale, they don't dilute their samples. So over 2,200 approximately counts per 100 milliliters on sometimes every single site, no matter where it was, whether it was in the headwater parts. There were very pristine locations here, whether it was down in the valley, whether it was at the outlet. So this got our attention, and we then really took advantage of this grant to try to change our sites a little bit, to try to understand more about it. So for the purposes of this grant, the main thing was to try to get out of the immediate basin of the Sparkill main stem. For one reason, everywhere on the main stem is also a place where there are sewer pipes, and very, very frequently those sewer mains are right underneath the creek itself. The valley for the Sparkill is the valley for the gravity system that feeds the 2 main, or at least one of the main sewer plants, which is also right on the Sparkill Creek. So we want to get out of that. There's still sewer lines around, but it's not this kind of basin with sewer lines. So, sorry about that. I'm discovering which one is the pointer. So here is a tributary. We went up that tributary to find out what was going on there. Here's a tributary. We went up that one to find out what's going on. The main stem, we didn't do so much. This is the Sparkhill Brook, which is the arm that's in the New Jersey section. We also tested more here. That was another one of our goals. Okay. Again, I'll remember what I'm doing by looking at the handouts. Oh, this is not good because these are the results. Yeah. Well, on this slide, were you looking at your slide? Yeah. Enterococcus. Yeah. Oh, I'm sorry. So Enterococcus, the whole protocol here is that it's an indicator bacteria that's found in the natural streams. Maybe you could try the PDF version would probably work. And EPA has determined that it's an indicator that there may be pathogens from sewage or some other source. So Enterococcus is not always so harmful. It's not necessarily good for you, but it's actually used in some veterinary formulations. But it's found in fecal contamination. It's very easy to test for as opposed to some of the other tests. So coliforms and some of the other ones are not easy to test for. So you look for Enterococcus to show you that there might be some fecal contamination. Is that close enough? It's a bacteria. No, it is. In my opinion, look, I'm a citizen scientist. So you're asking a citizen scientist what my opinion is. I say it's not necessarily proof. And the fact we know that there's many other sources for Enterococcus besides humans, and that's where the challenge is. But it has been shown to correlate, especially in beach studies. If you're right outside an outfall, in salt water and stuff like that. But that's maybe more for the question side. Great. Okay, so this is the only slide I have for my data. And let me just walk you through this. So on the left-hand side here is the Enterococcus counts. It goes up to 900, from 0 to 900. This red line here is the acceptable level of around 30. I can't remember if it's 30, 32 that EPA has established. And this is the geometric mean of all 15 of our sample days. So now a couple of these, this first one at what I call Tweed, it was dry very frequently because this is way up on the top of the watershed. It's frequently dry. I think all of August it was dry. And the last one, this little outfall here, we called Ferdinand outfall, was also frequently dry. So the data is not as good for those points. It doesn't have 15 sites by any means. In fact, it's less than 5. But so there's a tributary right here, these 2 points. There's a tributary, these 3, this one, and this one. There's a tributary here. And then the Sparkhill Brook is also a tributary, which is really kind of like more like a main stem. It's down in the valley. So those closed squares are the tributaries, and the open squares are in the main stem in the New York section. So what can you say from this? First of all, the counts are still quite high. They're all above what's considered an acceptable level. But this didn't surprise us. We basically have confirmed a lot of the results we've seen for past years. We also see that sometimes the tributary counts are just as elevated as the main stem counts. And even though the data is maybe a little weak here for this one is, I would say, within a couple hundred yards of the top of the watershed. It's in a park. It is very far from any habitations. There's one house, maybe in sight, but there are no sewer lines within a mile of this particular site, and yet it has about the same mean results as this final one, which is the final point before the Sparkhill goes into the Hudson. So basically, we're saying we still see very high counts, and they're still everywhere, even though in some cases, I think the sewer department may have a problem with this one, and I think I know why, but that's something to explore. But basically, we're seeing very similar results that we saw before. Well, here's well, we got half of the of the previous one. So here's our conclusion. We're seeing it, like I said, just said, we're seeing results that agree. Thank you. We're seeing results that agree with our previous work generally. No point sources are obvious in this work. We have increased our testing and our, certainly we've got identification, we've got testing, we've increased our understanding somewhat, not a tremendous amount, but at least we have a deeper understanding. And we still have some questions. One is, I don't think we need to do more testing on Enterococcus at this point, because I think we understand it with 4 years of work. But we're looking for a kind of a triangulation here. What other things we where do we? I listed some agencies here that we're familiar with. We don't think that you necessarily have the answers here, but what is our next step, and what are we doing next? That's so. Now beyond that, I'd like to talk. This is my last slide about our successes. Um, we've we've really appreciated the connections and the the Spark Hill Creek organization didn't have a checking account last year at this time. We'd never been to an insurance agent. We were working on our bylaws, but we didn't really see any need to do it very quickly. We've accelerated all of that just because of this grant and because of this project. I'm sure that we have a more elevated standing within our immediate community, and that the data that we've produced with EPA's cooperation is a lot more credible and will be appreciated by a wide range of regulators and people who look at this. So I think in terms of understanding, we have an appreciation for the challenges that we face, and we're looking forward to continuing work on this, regardless what format it is. And with that, we also are enthusiastic about going out and telling our story to anybody else that might just be starting here. So thanks to EPA and the Harbor and Estuary Program. And plus, I really want to also thank our fellow watershed, grantees, because I've had a number of discussions with all of you and really appreciate your help as well. So the questions actually are going to be for later, and that's it for me. Thanks. Sorry, thanks for your forbearance.
No, where's those?
Do you want me to sit here?
So next, we're going to hear from Myla Ramirez, who will be talking about the project that the Friends of the Bonsall Preserve did in collaboration with Montclair State University. Yeah, the questions are at the end. So this is to move the slides back and forth, and this is the laser pointer. So I just went to my slides, just to make sure. Oh. Hello. Can everyone hear me? Good. Hello, everyone. My name is Myla Ramirez. I am a member of the Friends of Bonsall Preserve, and I'm also a recent graduate of Montclair State University. So I was hired as the lead lab and field personnel for this particular project, and we studied the Third River, which is located in northern New Jersey. So New Jersey is a highly urbanized area, and it has the highest population density, particularly at the northeastern part of the state. Now, contrary to popular belief, New Jersey is not purely industrial. So we do have a lot of pockets of beautiful green parks and preserves throughout our state, and the Bonsall Preserve is just an example of one. Now, us at the Friends of Bonsall Preserve are its neighbors, and really, we just really work to protect and maintain the beauty and the ecology of it so that everyone can really enjoy it. So the Bonsall Wildlife Preserve is a little more than 20 acres in Montclair, New Jersey. There you can find a lot of short trail hikes. People use it for walking their dogs,
And then also we have the Third River, which goes right through it. And also with the university right up the street, we use it for a lot of educational purposes. And the number one question that we always get is, owners will, let their dogs and their other pets just go into the water and such. So the number one question and our primary objective for this particular project is it safe? Additionally, we wanted to possibly identify any sources of pollution. So one thing that we were also looking at was if there's a possible sewage pipe leak. So this is our actual Third River Basin, where you see the cluster of the 3 points. Well, this is all of our sampling locations, and we had a total of 10. The cluster of the 3 is the actual Bonsall Preserve, and we really just studied the main to the Hudson River. So we really thought it was important, additionally, not just the Bonsall Preserve, but to also just monitor. We chose our locations based on if they are parks or preserves, and really, is it also accessible for other people to go swimming into the water? So that was another primary concern. So our actual study design and methods, if you're not too familiar with it, we did June through August, 5 sampling events per month, 10 monitoring locations across the river, and our primary focus was Enterococcus, which is a bacterial parameter, and we used IDEX to measure it. But we also took water chemistry and field observational data to just kind of give us a general background of what was going on at the time of sampling. Just also for your frame of mind, for the Enterococcus, low was considered anything below 61 MPN per 100 mils. Moderate was 61 to 104. High was 105 to 500. And very high was considered 501, or anything above 501. Well, theoretically, this would be in our data, but just to show you, so we have 2 graphs that I'm actually going to show you, or 2 maps. So this is a picture of all of our data sites. It doesn't come out too clear, but everything is really from moderate to high. This is our total, everything from our summer months. So we specifically see high levels in one area of the Bonsall site, and again in a Nutley site, which is another park. And then what we kind of noticed with our data was it really fluctuated with specifically the amount of rain that was present. So, okay. That's fine. No, that's fine. Okay. So what you see on the left side is our total geometric mean for all of our sites, which we're able to label it depending on the town code to make it easier for everyone to understand if you're from the local area. So right off the bat, we actually see moderate to very high levels during the summer enterococcus. Specifically because of the rain. So what you see here is a post-rain event. So any type of sampling done within 48 hours of the rain. Clearly, you see that a lot of our Enterococcus levels triples and at even some sites quadruples. So we were able to identify 2 sites, B1 and N1, which is Bloomfield and Nutley. They have considerably high Enterococcus levels. And then again, here we have the map of actually being able to notice where they are on the main stem. And then with the post-rain events, we see that all of our levels are high to very high for 9 of our sites. So really, the takeaway that we were able to identify with our objective is the water safe for our residents to allow their pets and to allow their children to go swimming in? The answer was no. Especially after a rain event, we don't want anyone to really be submerging themselves under the water, primary contact level, so submerging your head under the water. And then going from here, the next steps of this was the first thing we wanted to do was to share our results. And we actually started this last weekend where we held an information session up at Montclair State University. And we had a really great attendance for all of the locals. We had about 30 participants. And we were able to talk to them and really kind of notify them what was going on right in their backyards. From there, we hope to establish a working group from our different community partners and to really talk with everyone to identify future tests. So whether we want to continue this actual pathogen monitoring or do we want to test for another parameter? Something that we're really hoping to kind of come out of this is an idea of Adopt a River, which is similar to an Adopt a Highway program. So everyone would kind of monitor their specific portion of the river and kind of report back to us and to see what's really going on. We'd just like to acknowledge the following people: the New York, New Jersey Harbor Estuary Program, Gabriella, the Interstate Water Pollution Control Commission, EPA Region 2, NJDEP, and all of our volunteers from the Friends of Bonsall Preserve, and as well as the PRI at Montclair State University. Thank you.
Yeah. I want to make sure that we give equal time to everybody, and then you can, it will give you a perspective of what each of the groups have been doing. If you don't mind, hold the question for the end. Well, go ahead. Go ahead.
So if you didn't hear the question, one of the comments, if you want to repeat it or I'll repeat it for you, is a lot of the contamination can come from a lot of the dogs that actually will go in, but it also can come from a newer number of other hosts, so wildlife. Is it human sources? So one of the things that we've been talking about is you can't necessarily go out and pinpoint one thing if you don't have the actual data to support it. So another step that we could be doing after this is something called source tracking, where you're actually able to identify the host through molecular techniques. So that could be a future test.
Most places test for E. coli.
Mhm.
Why aren't you doing it? Or why aren't Larry? Why would you guys test for E. coli?
Well,
I can answer.
Okay.
So between, I guess, there's different standards that we use. So obviously E. coli, fecal coliform, and Enterococcus are all different types of standards. For this particular test, Enterococcus, we didn't really know the tidal stage inference coming from the Passaic River because it is a brackish area. So E. coli is typically for freshwater standards. And even though the Third River is freshwater, we don't know the tidal inference, and Enterococcus can be used for both freshwater and for brackish and saline types
Yes,
of water.
actually, so the new proposed EPA standards can be based either on Enterococcus for any type of waters. E. coli can also be used for fresh waters. But for this particular project, we have groups in New York and New Jersey, and there were many different standards that would be applicable to each of the streams. And we wanted to do one single type of test that we could compare among all the sites. Okay, so thank you, Myla. And next, we're going to hear from Robin Kreisberg from the Bronx River Alliance, and she will tell us all about the project that they did in collaboration with Rocking the Boat.
Good morning. Thank you, everyone, for coming. And thanks to our funders for the opportunity to test for bacteria levels in the Bronx River. My name's Robin Kreisberg. I'm the Ecology Director at the Bronx River Alliance. And we work to protect, improve, and restore the Bronx River corridor so that it can be a healthy ecological, recreational, educational, and economic resource for the communities through which it flows. And we work in close partnership with the New York City Department of Parks and Recreation and our community partners, and on this project, Rocking the Boat. We have an extensive canoeing program as well as the wildlife that lives there. So just to give you some context, and I think we have everyone beat in terms of an urbanized watershed today. The Bronx River starts at Kensico Dam in Westchester County, and it flows for 23 miles, emptying into the East River and Long Island Sound at Soundview Park. 15 miles of the river are in Westchester County, and then 8 miles in New York City in the Bronx, and that's the section we work in. In Westchester County, the communities are served by separate sewer systems, and in New York City, we have combined sewer systems. And the total watershed area is approximately 56 square miles. This map is showing the 5 combined sewer outfalls located in the Bronx. They're in the tidal section of the river. It's very densely populated. The entire river corridor has been altered and impacted by human activity over the past 200 years, straightened for the railroad and the Bronx River Parkway, and marshes and floodplains have been filled in, and it's highly impervious surface area surrounding the river. And people, it's designated in the Bronx as safe for secondary contact, so not safe for swimming. We sampled at 9 sites during the summer, selected for a variety of reasons. The top sites 1 and 2 are right at the Westchester County border. Site 1 is right where the river comes in from Westchester, and Site 2 is at the mouth of an outfall pipe coming from Yonkers. And then the remaining sites were chosen for either access near a boat launch or near a combined sewer outfall. And so to get this work done, we partnered with Rocking the Boat, and we were fortunate to be able to set up a lab at their facility so we could run our own testing samples following the quality assurance project plan and protocols, and having our data checked by EPA staff. So during the course of the summer, approximately 130 samples were collected and analyzed, and of these samples, 34% were in the very high category of over 501 parts per 100 milliliters, which means they were not safe for full body contact. The worst sites in terms of the highest number of exceedances were at sites 1 and 2 at the Westchester border, and Site 7, which is Hunts Point Riverside Park, and that's where Rocking the Boat is located. Thanks to Corin from the Open Sewer Atlas, this map is a visualization of a dry weather day. So on June 2nd, the size of the brown dots indicates the level of pathogen of Enterococcus found in the water. The only place where there's a problem on this dry day is at Site 1, where the river comes in from Westchester County, as compared to a wet weather day when every single site exceeds 500 parts. And you can still see the red dots, which is where the combined sewer outfalls are located. So this Muskrat Cove, Site 1 at the Westchester County border, the blue lines are days when there was no rain, and the red lines are days when there was rain. And as you can see, even on dry weather days, they're very high levels. I mean, our chart goes up to thousands. And it's a very pristine setting, so we had a suspicion, but we really didn't know that we would be finding such high levels here. As opposed to Site 2 at the outfall pipe from Yonkers, where we see problems, but not nearly as bad as Site 1 and much more rain dependent. Hunts Point Riverside Park, at this site, the only days when we had exceedances were wet weather days. And this is near a CSO, so that's kind of what we would have expected. Dissolved oxygen is something else we've been concerned with, and this map shows the worst day for dissolved oxygen levels of the summer, which was August 18th. Anything below 5 is considered dangerous to marine life, and on this day, the sites that had the water was observed to be green, so we expect that it was due to algal blooms. And we've seen this every summer. This is the first summer we've been testing for pathogens, but we have been doing water quality testing for other factors for a number of years. What we've learned from this project is that we do have the capacity to do serious science with the support and training that was provided. And we drew the attention of other partner groups, which was great. It raised our visibility. And as a result, on August 18th, a bunch of different agencies and organizations got together for a major sampling day on the Bronx River. And that's what you're seeing here. And we're very excited that in the spring of 2015, we'll be opening the first fish passage on the Bronx River, first fish passage in New York City, which is at the first obstruction to migratory fish getting upstream for spawning, and it's at the 180th Street Dam, which was one of our testing sites. And then there are 2 more dams upstream that will get fish passages. They're already in design. So we're very interested in making sure that the water quality in the river will be able to support the fish once they get there and the other recreational uses that we do on the river. We do have some outstanding questions, and I hope that we'll have the opportunity to do more research to look into those, particularly around how the tides influence the results we're seeing, and that would be really important for people who want to use the river, knowing when it's safe and when it isn't and how long they need to wait. We've heard some theories that phosphorus is causing the dissolved oxygen problem in the river. We'd like to look into that some more. What's going on in Westchester County and looking for ways to partner more closely with them so that we can be working on a watershed basis to address our issues. And also, ideally, we'd love to be able to do this testing throughout the year so that we could see how the results differ seasonally. So again, thank you to our funders, New England Interstate Water Pollution Control Commission, the New York and New Jersey Harbor Estuary Program, and Rocking the Boat, our partner in this project. Thank you.
Okay, thank you, Robin. And so now, last but not least, we will hear from Alison Fitzgerald from New York, New Jersey Baykeeper.
Okay. Hi, just bear with me. I woke up with a bit of a head cold, so I'm sure I sound a little funny. My name's Allison. I'm from the New York, New Jersey Baykeeper, and I'm going to be talking about our, didn't realize I was dead, our stream monitoring plan that we did in Central Jersey this summer. Ooh, that was not the right one, sorry. I don't know what I just did. Sorry. Anyway, while that's loading, the New York, New Jersey Baykeeper is a nonprofit organization out of Keyport, New Jersey. We are a steward for the Harbor Estuary, so we cover New York and New Jersey. I actually happen to work for the oyster program in New York, so I've probably met a lot of you over the years doing the project in Soundview, and this is kind of a little different track for me and for us. We've never really done not actually a volunteer project. We did hire 2 college interns on this. While they are citizens, they did have science training, and we really liked that we could give them an opportunity to see what else they could do with their science background. We've been working as a steward for the estuary since the late 1980s to protect, preserve, and restore. I happen to work on the restoration side mostly. So why did we even bother to do this project? Why did we bother to do this in Central Jersey? what's the point of this whole project? Well, a lot of the data that all of these groups collected is really useful to the EPA, the New Jersey DEP, or their New York counterparts in order to provide information on water quality in our watershed, which will then lead to different policy decisions, right? We can use these pathogen indicators such as Enterococcus bacteria or E. coli bacteria to analyze the anthropogenic or man-made inputs into the estuary. And we can also, at the same time, train these citizen scientists on how to collect and analyze useful data that leads to knowing more about stream health and watershed health. So why did we pick these two sites? Well, most of the reason that we picked it is that they're in an area that the NUEPEC, HEP, DEP, all of the governing agencies decided was a high priority. We are located here in the lower Raritan River watershed of the Harbor Estuary. And this was an area where they didn't really have a lot of data. Yes, we do not beat Robin as the most urbanized area, but it is a pretty suburban area, very highly populated. There is a lot of industry, and it varies from industry to very pristine. So it's a really interesting area. And the data that we collected could be used to implement future pollution controls. So that's where we are. And this is where we specifically are. Oh, this is kind of hard to see, but just to orient you, because it's a little difficult. Here's Raritan Bay. So like Staten Island would be up here. And here's the Raritan River. And we chose these two rivers, South River, which is completely in Middlesex County, New Jersey, and Matawan Creek, which straddles the border of Monmouth and Middlesex. Our office is actually the rest of the groups in here. We had a 5 times a month sampling plan. At least one of these dates came after a rain event. Why? Well, part of the project was looking at Enterococcus levels due to pollution runoff. Right? Runoff and CSOs, combined sewer overflows, the input into the streams would increase a lot after a wet weather event. So we wanted to be able to capture that. At each site, we used a YSI, which is a handheld device to measure physiochemical data, which is just a fancy word for saying temperature, salinity, dissolved oxygen, pH. We took a GPS location. We took water samples. We happened to only measure the Enterococcus. That was what the EPA had us do. We also, something that the EPA did not ask us to do, but we thought was a good collecting data, was to use a Secchi disc, which is a device that you can lower into the water, and it will tell you the depth of visibility. This gives us a parameter to measure how much sediment's in the water, which can impact a lot of the levels of Enterococcus that we're looking at, the health of the stream. If there's too much sediment, a lot of the organisms can't survive. We also took observations on weather and point source pollution. This is actually a little outflow pipe. We didn't notice this for the first 3 weeks at one of our sites until the water level dropped really low, and then we happened to notice it. So when the water was a little high, it was completely submerged. We didn't actually notice it. All right, so what did we learn from all this? These are our 2 interns here, Chi and Gia. First thing we learned is that, holy cow, we collected a lot of data this summer. I took this screenshot of our Excel sheet to show you that we had almost 4,200 lines of data at the end of the summer. There is such a thing as too much data sometimes. We measured 28 different parameters per site, per date. We had 15 dates over the summer. I didn't do the math on that. I'll let you do that. And so the real task at the end of one of these types of projects is, what do you analyze? What's important to know? What's going to actually provide data to the groups? So what we tried to focus on is the ecological impacts of these parameters. What's going to tell us about the health of the watershed? Okay, you need a reason to analyze the data. You don't want to just be looking at all these numbers for no reason. So what's going to give us really usable data? Well, we can look at the temperature, salinity, and dissolved oxygen, all of those things that the YSI measured. That's going to give us information on parameters that would affect the health of the organisms in the stream. Okay, we can look at the Enterococcus. That's going to tell us about the health of the stream with respect to, can humans go in it? Is it safe for primary contact, secondary contact, etc. That'll also give us information on how much of the water on land is washing into the stream during a rain event. Okay. We should look at the weather. Did it rain 24 hours previous to our sample, 48 hours? Was it a dry day? Was it really sunny? Was it cloudy? All of that can give us information that affects all of the other stuff, the temperature, salinity, the enterococcus, that's all affected by the weather patterns. And we can look at the point source pollution. Well, this again will affect how much enterococcus is in the river, how much we need to know. So I just included a few things that we started analyzing. So first of all, this is our DO. These graphs are crazy crowded, but I didn't want to make a couple of different ones because I thought that it would go to my point here if I just showed you. So along the bottom here, we have all of our different sites. M is Matawan Creek, S is South River. And what you can see here is that they're all pretty much grouped between the average of about 11 and let's say 4, okay, which is not bad. 2 is considered hypoxic, anoxic zone, so we don't really want to go below 4, but below 2 is very bad. But something to note about these dissolved oxygen measurements, not for our group, but for all the groups. This is what we call a point measurement. It's a single discrete measurement in time. That doesn't mean that for the entire summer, you know, the whole time this was down here. It's one single measurement, whether we went in the beginning of the day, the end clock with a sonde or a probe that you can leave in the water, or it's every day at the same time to get an average. But this is just one single time, 5 times a month. So that can all change. But from what we're seeing, our rivers look pretty good. If we look at the temperature, same thing. We obviously, as the summer went on, it increased. That's good. It was nice and warm this summer. July was very warm. And so we really don't see anything on this graph that would indicate a difference in the health of the river. Okay, so the important stuff. Here's the enterococcus. What I graphed was actually the geomean. I hope I did this right. I was trying to listen to Stan's advice. But it was the average of the 5 dates that we took each month. And so you can see here, wrong button. Our South River generally has higher, but we have this one kind of anomaly here, M3, which is our third Matawan Creek. This is right at the point where it switches from saline water coming in from Raritan Bay to a more freshwater system. And for some reason, this one just steadily increased over the summer, and I'm not really sure why yet. Something else I plotted was rain. So how does a rain event affect the enterococcus? Well, what you're looking at here is the geomeans for June, July, and August at our different sites. And then the black dot is the measurement on what we term the rain event sampling, so the date right after rain. So you can see here, at most of the times, except for August, our single measurement on the rain day was higher than the average for the month, okay? What that means is that after a rain event, there is a significant increase in the amount of enterococcus in the river, okay? And you can see here, South River is consistently more so than Matawan Creek. And something I wanted to really point out here, this goes up to 300, this goes up to 160, this goes to 1600. Right, so there's a huge jump in the magnification of enterococcus in July, probably due to the fact that we had a lot more rain in July. This is from New Brunswick, average rainfall. I just Googled it on the NOAA site. We had over 7 inches of rain in New Brunswick, which is the closest weather station to where they are. More rain equals more runoff going into the water equals more enterococcus. All right, so obviously there's a lot more data. This is all we've really analyzed so far. But what can we do with this? What do we want to do with all this data? Well, this data can influence policy decisions around our watershed, not just in the Raritan area, but in the whole Harbor Estuary, okay? We can add to the growing database of citizen science. Citizen science is great. We can get people out there. They help us collect the data. It benefits both the agencies collecting the data and the scientists doing the collecting. They learn a get involved with something that they don't normally do in their daily lives, learn a new job skill, learn a new hobby, whatever it is. We're hoping to get more citizen science projects about this and increase training sessions around them and educate members to build engagement. For this project specifically, what did we like and what did we really need to fix? Well, we liked using the GPS. This was something we hadn't really done before, using a handheld GPS to get an exact measurement of where we are. We have used a YSI before, and we do really like that. It gives us a nice, discrete measurement in time. And also, we're going to expand the college internship program. We thought that our interns really got a lot out of this, and we got a lot out of working with them. What will we fix? Well, for one thing, the site access with this project, we had actually picked like 5 of the 10 sites were different at the beginning, but we realized we couldn't actually get to the site. So that's something that you kind of have to scout out a little bit more before doing a project like this. And also, we would measure both Enterococcus and E. coli. E. coli has been shown to be a better indicator in a freshwater system, and we would like to compare them to see how they differ between freshwater and marine. And that is it. And I guess since I'm the last one, I can say questions. Yes, you can.
Gabrielle, could I take 10 seconds just to say one thing?
Sure.
Yeah, I really apologize. I just want to recognize our group members that are here today, and I forgot to do that. So if our people from our Sparkhill group can stand up, I just want to show that we are dedicated to attending. Thank you.
Okay, well, thank you very much for all these great presentations. So we can, we want to open the floor now for questions from the audience. We have, first let me check, do we have anybody on the phone? Anybody on the phone? Okay. So, okay, we have one question. Can you speak up a little bit?
I'm going to defer to Debbie, our executive director. I was more the on hands person. She's more the policy person. Debbie's going to answer.
Wait.
For New York, New Jersey Baykeeper, and I work with Allison. So that's a policy question, right? And it was very important to us as a group, and this is our mission, about that the data is used to make policy decisions. And I have to say, Danielle's here from DEP, and she's been, New Jersey DEP, she's been very helpful to us and talking to us and helping us with the program. But it's unclear right now whether or not our data will be used for things like the 303D list, the Clean Water Act requirements of how the state assesses its water body and whether it decides to put those water bodies on a TMDL or a pollution budget. So I think that's still an open question. I think, as Allison mentioned, doing more of the E. coli testing would have helped. We're also interested in this for shellfish reasons. We're trying to restore oysters, and New Jersey's telling us the water's too polluted to do that. So we're trying to figure out how to use data to get to a place where we can make better policy choices. But that being said, Danielle's been really great.
Do you want to say something, Danielle?
Sure. So one of the things is that we've known that this project has been going on, and we have been at the table as often as we can as far as providing input to EPA and to the grantees. So what we have to do now with all the data that we get for our assessment purposes, right, is we have different purposes at the agency. Sometimes we use data for a screening tool to identify that we may need to go out and do further sampling, that we may need more sampling. So as with all data that comes in for the integrated report process, which is essentially the report card of the state's waters, is we look at the quality assurance plan, we go back and we look at the data in draft form, and we confirm that what was supposed to be done was done, and then we look to see if we need to really focus in on E. coli or the other parameters. And that really depends on if it's saline waters or fresh waters. And that's one thing that EPA and I were talking about and realized that we may have to tweak a little bit for the next project. So like all data of known quality, we consider it.
Yeah, one. Okay.
Kara Musio, Clean Ocean Action. I have kind of a follow-up question related to that. It's a little bit technical, so I'm sorry. One person on the panel mentioned this, that you use the IDEX Enterococcus system. And I'm just curious if, because it was a joint project, if you all use the same water quality testing system, you all use Enterococcus IDEX, and if there was any in your QA plan for the project cross-testing with method 1600, because that's one of the issues that we've run into working in the coastal areas with the New Jersey State DEP, or if you just solely use the IDEX system.
Maybe I can address that. Yes, as you say, we had 4 groups, and one objective of this grant was that the groups were going to be in charge of the full process of collecting the data and analyzing the data. So we went with one of the IDEX kits, which our understanding, I mean, it is an approved method, an EPA approved method. So yes, everybody used the IDEX test. And I don't think that there were, oh, Jim Ferretti is there. He can add. Great.
Yeah, the question came up during the study. Different methods. When you're using different methods, inherently there's variability associated with them. So anytime you use a method, I guess, the perception is the Enterococcus is a lot higher? Is that what you're hearing overall? Yeah, and that happens, and that can happen with any kind of method. But what we did do, there were 2 labs that were doing testing out of our EPA lab, and
I'm sorry, Jim. Can you repeat broadly what she, for the people in the webinar, so they can hear?
During the project, was there anything else conducted besides the IDEX Enterococcus test, specifically using a different technique, membrane filtration, which is more traditional for bacteriological analysis? So just because we heard of variability in all these types of tests, we did run some split samples at the EPA lab using membrane filtration. And we have not shared that data with the groups yet, so, but we will. We did a split sample every month for 2 groups. So I can tell you the overall trend was the membrane filtration results were twice as high as the IDEX Enterococcus. And going in, my expectation was it was just going to be the opposite. So I'm not sure how we can, there's a lot of reasons for that type of variability, whether it be dilutions, whether it be, for instance, the IDEX test tells you there are some organisms that can cause a false positive. But there's also false positives that can occur with membrane filtration. So the fact of the matter is, when you have concentrations that are in the thousands, you know, I think you can reliably say, even if you take into account variability, that you still have issues with pathogens. So we're looking for general trends here, and I think the IDEX test worked well.
And to kind of answer that question as well, so I work with the Passaic River Institute at Montclair State University, and we're really familiar with the method 1600 and all of the membrane filtration methods. And there are limitations that you really want to consider when choosing method. Membrane filtration is very intensive. It requires a lot of work compared to IDEX was a fairly simple process, and I'm sure we can all attest to that. And if you'd like to discuss further, like since you're kind of weighing the options of what methods to use, if you kind of want some advice or just want to talk about it with someone, we can definitely do that for you.
Thank you. Any other questions?
There's a bunch from the web, but I need to sort through
Okay,
them.
let's take 2 more from the audience, and then we'll take some questions from the webinar. Let's go there.
Hi, Lauren Alleman with the Nature Conservancy. I'm just curious if anybody thought about doing any benthic macroinvertebrate monitoring or any kind of biological, like any animals, any wildlife. That's really fun to do with citizen science participants, and it's also really informative because it's more than just a snapshot of just a one point in time water quality sample. So kind of a suggestion and a question.
Okay, let me say something overall. From our perspective, this is the first time that we do a citizen science project, so we had to limit what we do the first time and sort of test it, and then from here we can go other places. But then I'll let the groups answer about their plans. Anybody? Okay, let's go around.
So we did not do that because it was not in the scope of work for this project, but you're correct. Having some sort of biological data is really important. We do that at the component, because you're right, you need some sort of way to relate all of the data that we gathered to what's actually happening in the stream. But as you saw, we had a lot of data to gather anyway, so it was hard to add extra things on. It just, you only had so many hours to get the samples to the lab for the Enterococcus testing. And so to spend more time at each site, we wouldn't have been able to get the samples done in time.
So for us, as I mentioned, this project attracted the interest of a lot of other agencies, and we did have one-day intensive sampling of all different types of indicators, including clams and snails and aquatic plants and macroinvertebrates. And we're hoping that by attracting academic institutions and other partners, we can begin to put this all together and make more sense of it.
So specifically for this project, we obviously didn't use it, but in general, at the Friends of Bonsall Preserve, we like to do like community and family days. So macroinvertebrates, if none of you guys know, it's really, really fun to do, especially with children. It's a really great way, hands-on way to really get them involved, get them thinking about water quality. And also for everyone, it's a really cool thing to do with high school students or with other, younger kids, 8th grade and younger. So that's something that we do at the Friends of Bonsall Preserve, but it's also a really great recommendation for everyone out here to do, and it's very simple to do as well.
Again, I think that's, yeah. We did not include this for all the reasons before. We had 7,000 lines of data, so there was a lot to do, and we were very nervous about not getting everything done on the sampling days. But our group has conducted these things with various volunteers, including ourselves, and it is available on the Rockland Soil and Water Conservation part of the Rockland County website, and there's a New York State program, and we've done a couple sites on the Spark Hill over the years. And there's a kind of summary of this called the I think it's called the Stream Report Card that's available on the county website.
I just wanted to touch base too about data use. I think I just want to take a moment to say to all of the groups that your work and your level of commitment and dedication was amazing. And to start the project with a quality assurance plan and training and equipment and data management and field obligations starting in April and having this all complete by August is like commendable, and it's really a push. So I'm hoping that these organizations use this as a learning experience, and then they're able to continue developing and their programs and growing. And the big component is that even though this may or may not be used for final assessment purpose at an agency, you're already using it within your community. So that's really where the power is empowering yourself to be able to have these conversations with your community.
I'm asking a clarifying question from Deborah Waller, so I'll get to that one in a second. But I'm going to reframe Chris Bickford's question a little bit. Sorry, Chris. I think it might be sort of more generalized when I state it. But basically, he talked about how in camping, you sort of have this 150-foot rule from being near the waterways. And it's sort of a way that you can kind of prevent impacts to your waterways. So what he wants to know is more or less, how do we actually deal, if we figure out what the source is, whether it's human pollution through sewage or CSOs, or maybe it's walking your dog and letting it poop on the side of the stream. So what are our options for addressing all of these different issues?
could try to put that in context a little bit. These are suburban streams. Or a few humans next to it. We would love to just pull back people out of the riparian zone, but a lot of these areas are just built out already. I think more the challenge is to find out where the old septic systems are that aren't being used anymore, things like that. In the headwaters, I agree with them. We have a park and pretty much protected areas, and we can employ those kinds of things. But down in the valley, it's another world.
I'm wondering if you can answer the question a little more generally, just sort of, what are our options for dealing with the bacteria in the water based on the fact that they're coming from multiple sources, and we sort of have some idea about what that range is.
I wish I knew the answer to that question. And maybe I'd like to hear some of the other people. I think first is to characterize the nature of the sources. We have done a little work outside of this with DNA testing and finding out whether we've seen generally indications that 25% of some areas or more are from plant-based, not even from mammal-based Enterococcus. But these are very general indications, and we'd like to do more of that. But I'd like to hear from some of the others.
Yeah, I mean, it's a very complex question, but one thing I'd like to say is the Bronx River Alliance works hard to get people down to the river and get them to enjoy it and appreciate it so that then they will be supportive of any actions that are needed to clean up the river. And in New York City in general, with the combined sewer overflow issue, there's a huge green infrastructure program going on. I'm sure most of you have heard about that. And that's a great way of both absorbing runoff and using it as a resource. So greening the city, keeping water out of the combined sewers, and making the neighborhoods better for everyone. We also work to improve the habitats along the riverbank and help them absorb more runoff and reduce sedimentation and green them. So building parks, doing habitat restoration, implementing green infrastructure throughout the city. And even in the suburban areas, there are opportunities for rain gardens and rain barrels and different approaches to use water more where it falls and as a resource.
Also, to kind of just go off of that, it's so fecal pollution, especially when we talk about coming from a non-point source pollution source, I don't believe it's regulated. So it's really hard to kind of say what can we do right now to kind of, regulate our input. But again, it's like to identify the hosts really and to be able to pinpoint, well, is it really the human? Is it the CSOs? Or is it the wildlife and things of that sort? Or is it the agricultural areas, if any of us have that in our areas?
I agree with what Robin said. Knowledge is power. And, part of getting the policy written is to get your thoughts heard to the regulators. And so doing projects like this with citizen scientists and gathering this data just gives us more evidence to present to the regulators to have them then put the policy in effect. We live in an extremely urbanized watershed, and it's hard to stay 150 feet away from the water. And especially when you have CSOs in place or impervious surfaces, you really need to just start at the source, the humans that are putting the wastewater out there.
Okay, well, I think that's all the time we have for questions. So thank you very much to all the presenters. I believe Sparkle Creek has something they want to say.
Acknowledge our appreciation to Gabriella and to all of you who trained and made the grants possible. And it was really on behalf of all of us here working with the streams. We have some artists in our group, and we like to always make sure that we find every possible way to give a voice to the creek and to the waterways. So we have an art piece to present to Gabriella and individual pieces, if you could see that they get to the members of your teams. So this is a replication of a creek. with stones from the headwaters of our creek that we collected 2 days ago. And so I don't know if you can all see it, but it's the individual stones and they have streams painted across the top of them. And it's just a voice for the waterways.
Well, thank you so much. That's beautiful.
Thank you.
Yeah. Lori Seaman is the chair of our group and has been really the spearhead for the last 4 years on this, and we really appreciate her leadership. Thank you.
Okay, so before moving to the final panel, I just wanted to tell you a little bit. Yeah, I think and there's going to be some introductions. Oh, okay. If you can put my slide. I actually don't really have a slide. I just want to show you the contact information, but I just wanted to give you a brief sense of where we are right now at the Harbor Estuary Program with the citizen science. We really consider this project to be a success. As you've heard from the groups, that they've done a great job, generated lots of useful data, and they are now sharing all that they've learned with us. Well, one thing that we said to do was to help them support, they can really do that. And more importantly, all of these groups have learned a wide range of very useful skills that they will retain and be able to apply again and probably share with others. So that's a great thing that we got from this project. And we've also at HEP and the other partners, we've learned a lot of we learned a lot of lessons and got new perspectives on citizen science and how we can help. You will hear later from Pat that thanks to this project, also EPA was able to create a number of tools that will be available as a resource for any group wanting to start a citizen science project, including quality assurance project plans, standard operating procedures, data sheets for field and lab operations, and one of the main challenges that we have ahead is being mindful that we have a very limited amount of resources. How do we put those resources to work in a meaningful way? How can, what's the best role for HEP and partners to play to support citizen science? And we're really interested in continuing to provide resources for citizen science in the future. So now we are in the process of evaluating this first grant cycle and working with our partners to figure out what's that role that makes sense for us to play within our means. So we're also learning a lot today from the different groups, and we are very interested in hearing from other citizen science groups as well. What are you doing? What are your plans for the future? What type of support do you really need the most? Citizen scientists in the group, in the room, or if you know others, it will be, we would really love to hear from your experiences. Let us know, what you need, how can we best help you, and we will, take that into consideration when we think about the future. And as I said, there's printed copies that you can fill out today and give them to me or Kate or Rob. But there's also a link. You can do this online. You can share with others, and we will make sure that we will follow. An interactive online map, which unfortunately doesn't show very well in the screen. But if you go to our website, you'll be able to get there and see all of the data. It's not complete yet. We're hoping that it will be final sometime next week. It will have all the data. You will be able to download the data or play with what you can display on the map. Touch with me at any point. The link there, that's the link to that questionnaire that I was talking about. But as I said, I'm going to share that with you in multiple ways, and I'm going to be bugging you to give us your feedback. So now we turn to the panel to talk about the future of citizen science in our region.
Great. So I guess just to invite all the other panelists to come join us at the sort of hearing from the agencies and getting their perspective on the program and how this worked. And again, we've asked people to give very brief presentations, and so we'll have, again, time for questions and answers at the conclusion of their presentations. So I'm going to just keep talking as people are gathering here, but just to briefly introduce all the panelists right now, and then we'll let them talk in turn. We're really pleased to be joined by Venetia around in both environmental work as well as waterfront work around the city. Pat Sheridan has been with the U.S. EPA Region 2 office for over 26 years, serving as Technical Project Quality Officer and Quality Assurance Officer for a variety of programs, and is the Citizen Science Coordinator. A specialist for the New Jersey DEP, and have been doing this work again has a long experience of working with citizens all over the state of New Jersey on this and other citizen science programs. And finally, Sam Marquand from Rocking the Boat has been is the Environmental Job Skills Program Director, great title, and has been working panel. So with that, let me turn to Venetia and give her the floor. And again, I think what we'll do is have everyone talk. We'll get all the presentations and we'll save the Q&A for the end. Thanks.
Great, good morning. Again, Venetia Lannon. I'm the Regional Director for Region 2, which is New York City for the New York State Department of Environmental Conservation, DEC. And thanks for having me. This is something I'm really interested in. With you what I think is potentially an interesting precedent for DEC with citizen science. It's the Citizens Statewide Lake Assessment Program, which has the somewhat unfortunate acronym of CSLAP. But CSLAP was started in 1986 with the Federation of Lake Associations. And it started as a pilot project with just 25 lakes. Now it's up to 125. A marine waters program based on CSLAP. And as we think about that, CSLAP is instructive, I think, in a couple of ways. One is how it was formalized. It was put into the state budget, really, as a line item in the state budget, both for DEC to fund a coordinator, for DOH, who initially did the data. As a line item, And then because you know that budgets can fluctuate over time, it was actually put into the environmental conservation law in 1987 that it sort of says the state shall provide for this service. So, you know, I think that's an important model to think about. How do we formalize this? We all like it. We think it's doing good stuff, but you know, if we want to make it permanent, we need to think about permanent structures. We at DEC actually use the data that is gathered by these citizen scientists in this lake program to make determinations about 303D listings and to also have formed policy regarding invasive species in lakes based on this data. And so and this program is obviously largely upstate with the lake associations, but what my colleagues tell me up there is really important is that we really need to collectively agree on what, you know, what do we want to achieve with this data? You know, what is it that we're trying to solve for? For example, in New York City and in the made. But I really would love to engage with everyone here this morning to be thinking about, you know, what is it that you would want the regulator to do with this data? I know, for example, when I went to the great event that the Bronx River, sorry, there you are, Danielle, I was looking at you over there. I went to the event that the Bronx River Alliance and others coordinated this summer that you saw in the Bronx River Alliance presentation, which was fantastic. Down. I mean, there's actually a very formal investigation into what those sources are, but we've started to work together to understand the impacts that are occurring across regions, you know, with the Bronx River. So there are things like that, you know, that I think with track downs, with of illicit discharges, illicit resources for enforcement. And so if citizens can help us kind of focus our investigations in particular hotspots where you're seeing, you know, upticks, that's something to think about. But I think, you know, I think CSLAP is an interesting model, and I really look forward to engaging with you all to think about how to formalize citizen science started, and how do we kind of make it last, and how do we make it meaningful in the exchange with the regulatory community. I'll leave it there. Thanks.
Yes, I have two names. Good morning, everyone. My name is Pat Sheridan. I'm the Citizen Science Coordinator here in Region 2. I am out of our Edison, New Jersey office, which is the Division of Environmental Science and Assessment, known as DESA. We'll continue with the acronyms because the government has many. Oh, to the right, change my slides. Okay. I'd like to give you first a definition of citizen science that we have crafted organizations. And the number of citizen science projects has definitely increased and dramatically over the past decade. We have tools that are now more advanced, and we have people in engaging the community to know their environment and really leveraging change. That's kind of what they're doing out there. And for Region 2, we had to look at it from our perspective, what we needed. And we needed to really look at it and understand that there are many different projects that are done with, whether it's and it's not changing. It's this one, right? Oh, here, I'm sorry, I got it. Okay, is that better? Yes, it is. So in 2010, our regional administrator, Judith Hank, made citizen science a priority. And a lot of that was focused on giving citizens and community groups the instruments to do the sampling. And this was highlighted by 2 events that happened. Took action by sampling in their community. The other one was in Western New York, where there was a community-led effort to sample with a bucket brigade. This was done over a couple of years, starting in, I believe in 2006, to reduce the benzene emissions out of Tonawanda Coke. She's really a go-getter, and if you know Deb, she gets things going. So we started a Region 2 citizen science workshop internally with divisional representatives, and we were charged with creating the program. So Deb was charged with conducting interviews with EJ groups, community groups, academia, government organizations to find out what are the needs and concerns of citizens. So given all that, we came up with the first ever, in June of 2012, Citizen Science Workshop for EPA. It was held over 20 of our speakers, and 5 of those videos are actually on our website now. But from that, what we got from you guys was that we want 2 things. We want to know about funding opportunities, and we really want our data taken seriously with the tools to do so. So Region 2 then went on to provide funding to 6 grants, 5 in New York and 1 in St. Croix for air and water pollution. We used something that we called hometown grant discretionary money. From there, we work with our counterparts in, here we go. We then work with our state counterparts on the community air screening program at DEC, in which 23 individual projects were done, and an instructional video on how to sample with a Suma canister is on their website. It was very successful, and I would recommend that you check out the website and the instructional video. We went across the river, and we also gave DEP some monies as well, and that was funding air projects in both Newark and Elizabeth, New Jersey for black carbon. We had water quality monitoring projects that were funded as well with clean water money, and that was with New York and New Jersey harbor projects through the state and through our HEP counterparts, and the Mohawk River with DEC. To address the second part of this one is to address sound and defensible data. Region 2 hosted a My Environment webinar in March of 2001, which is a GIS tool that will engage citizens in looking at their communities under My Air, My Water, My Land. It's very interesting and very useful. This was followed by a quality assurance training seminar, a series that we held in our New York and New Jersey offices again, as well as of what you heard, the 4 projects today. The project used sampling that was loaned by EPA. You were trained from our laboratory staff, and it served basically as a pilot for our project, our equipment loan program. Our accomplishments continue with our ORD, with our Office of Research and Development. There's a list of acronyms there, which I can't tell you what they are because I'm not with ORD, but suffice to say, they are project funding mechanisms that we did throughout Puerto Rico. We've done them in New Jersey as well. And we had a successful Office of Research and Development and a National Institutes of Health and Environmental and Health Sciences in My Air and My Health Challenge, where some of the speakers from our workshop actually had prototypes they have developed for air monitoring, and they were demonstrated there. We developed a citizen science flyer that we use as a communication tool. And at this point, it took 1 year to actually post the first citizen science video that we interviewed back in our 2012 workshop. We revamped our existing Region 2 Citizen Science website. It was a bit of a shell of a website, but through our leadership development program here in the region, we were able to really, expand it and include a lot of different information. And we also streamlined our quality assurance project plan to include a citizen science a template that's easier to use, much more streamlined, and something that they used in the 4 projects that we heard about today. So in 2014, we finally posted the last 4 remaining videos, and it took 2 years to do that. We continued targeting funding with our Office of Research and Development, and we were doing an air deployment, an air center. Started now. The sensors are actually being delivered within the next week, and we're going to start arranging them and taking them out to site to test the site that the Ironbound community has selected for this project. We continue to work with ORD, the next generation, and this innovative team of scientists and engineers, as they are the ones that are evaluating and identifying the various sensors that are coming through. And we actually turned our focus in 2014, and it took a whole year in planning. We took our citizen science program to our Caribbean group of territory and academic partners. It was a 2-day event that was covered. We covered Caribbean science, and we covered citizen science on the second day. This is an area that, if you've ever been to Puerto Rico and some of the areas that are not the resort areas, you will see that there are a lot of environmental issues and health concerns that, they don't often get noticed. So putting the funding there, taking our show in the we are in the process of developing our equipment loan program. The project that was done today with the 4 grantees served as the basis for the water program that we have for the equipment loan. We will be using the same equipment that we lent out to our grantees, the kits, the SONs, the GPS, and the documentation portion of this is the quality assurance project plan, the field and lab data sheets, and the guidance in the SOPs. So our goal, and it goes back to what you asked of us in 2012, is to have our data taken seriously, and we want the tools to do so. So this whole equipment loan program, between the equipment and the documentation that we're providing you in a toolbox, that's what we're calling it, will help you get there. We understand that, to have this information, it increases quality data that's being collected. And I will quote Deb Zaro, because she was very good at this. She always talked about quality in terms of a sliding scale of quality. So something that's educational or engagement may just be your observational data or some of your monitoring data. If you're looking for something that's more for efficacy or to take action, you're going to have a higher level of monitoring data and a higher quality that will be needed. But the tools will be there in the toolbox for you to use. The quality assurance plan will get you there. But you have to think about this, you have to identify your goals. And it was so plan or project, you really need to have those goals laid out. So we hope and we understand, and we will push forward in 2015, that citizen science data can be credible, can be defensible. You need the tools to do so, and to get it where the states, if they should decide to use it, you'll have it at least in that format that will raise some kind of awareness, not only to communities, but to the states, whether or not they want to leverage that for their uses. And I hope that you will check out our website and check out the DEC website. And I guess Danielle? Yeah.
Can everybody hear me? I have so much energy about this topic that I wouldn't be able to sit. So my apologies for not sitting in the panel. My name is Danielle Donkersloot, and I'm with the New Jersey Department of Environmental Protection. And I have there seems to be interchangeable discussion between the term of volunteer monitoring and citizen science. Has anybody else noticed that? You hear volunteer monitoring sometimes, citizen science other times. And really, there's a distinction that we're making at the National Water Quality Monitoring Council level, which is citizen science is more of a top-down approach, so that there's a project and we need people to collect information and collect data and plug people into that. And then there's also short-term commitments. So you as a citizen scientist know when you need to go out, and you know when the project begins and when the project ends. But you have volunteer monitoring is more of a bubble-up approach. It's more of a community-based approach. This is where your community has identified a problem, and you're trying to identify the solution for that problem and raise awareness around the community. And it's a longer-term commitment, and it's actually usually more of a financial commitment, more of a resource commitment to the folks involved. These definitions came out of a white paper that was done about public participation in scientific research. And you can get this information from Gabriella. Can you all see that chart? Okay. So it's really just to talk about contributory projects, which are the citizen science projects, and then co-created projects. These are projects where your professionals, your advocates, your academia, your government agency, your not-for-profits, and your citizen scientists and volunteer monitors all work together to identify the questions of the study, develop the study, collect the data, analyze the data. So really, volunteer monitoring is more of that bubble-up approach, and it's much more time-intensive commitments. So if you weren't able to see that on that slide, just briefly, the contributory project idea of citizen science is to collect the data, disseminate the conclusions, and translate those results into an action of what the community can do. Where you have that co-created project where, again, it's everything from developing the study to collecting the data and analyzing the samples and discussing the results, and then posing new questions. And I liked the fact that the one group, the Bronx River Alliance, actually came up with a whole new set of new questions. And that's how the scientific process is supposed to move. That once you've gotten to where you think you are, there's always new questions that come up and come out of it. So right now, focused on creating a citizen science program for living shorelines. And this really touches on coastal resiliency projects at the state's level. There's a lot of players involved in living shorelines, and the whole idea is to make your coastline more resilient to sea level rise and to a host of issues. Really, that were an eye-opener to us was with Superstorm Sandy, Hurricane Sandy. And when that came, we realized how vulnerable our communities were. So I've been retasked with creating a citizen science program related to living shorelines and having citizen scientists monitor for living shorelines. So I started doing this in September, and I already have lots of questions, and I'm trying to put these pieces together. There's engineers, there's funding, there's partners and planning and rules. But really, we're honing in on a few things, a few goals for our citizen science with living shorelines. And that is to identify potential project locations, areas that you may know of within the coastal zone, within the tidal zone, that could really use some restoration efforts or could really use some resiliency efforts to make it more resilient for the next storm or for what's happening 20 years from now or 50 years from now. And then really also taking a look at and using citizen scientists to monitor the effectiveness of coastal resiliency projects from an engineering perspective and from an ecological perspective. So the engineers, you know, they build a project and think of these projects as not your typical, let's put an 18-foot wall bulkhead around it and we'll say that our community is resilient and we can handle any storm. You know, this is really bringing living attributes to these projects too, right? So the idea is that is what we're trying to do, is it working? Is it not working? You know, this is a new way of thinking about engineering, and we really need to define if it's working or not. And the next thing we were focused on really on too is the ecological goals. Is it being used for bird habitat? Are migratory species in there? Is the whole area covered with invasive species? Or is what we put in, is it living? Is it slumping over and falling into the wetland? So this is the focus. And then really, again, where the citizen science strength is taking that data and turning it into an action at the local level. There is a monitoring and metrics work group going on right now with a Southern New Jersey focus, and that's led by the Nature Conservancy. But you'll see there's a host of partners there: NOAA, Stevens Institute, Partnership for the Delaware Estuary, the Barnegat Bay Partnership, the American Littoral Society. We're sitting around the table and we're saying, well, how do we monitor these things? And really, what makes a good project? We really projects that are falling into this realm of what we call coastal resiliency. For example, there's projects out there that are saying, let's build the marsh up, right? Sea level rises, let's keep the marsh going up too. There's other projects that are like, instead of just doing bulkhead, let's put some living shoreline in there. Let's start in the water and work our way up with plants, with oyster banks. Our goal at the state is to not only have a South Jersey focus, but to really turn this into a New Jersey Living Shorelines Committee with internal and external partners, with the expertise that we have in this room. I know there are people here that are going to feed into this process for us to make this a viable process, to make our communities resilient to what's going to happen in the future. So our goal is to really focus in on the science and the regulatory requirements as it relates to permitting and dredging and engineering. And we will be working with partners in the north as well as the south part of the state. And we're interested in finding participants. So I was trying to figure out a way of coining another acronym because I've worked at government for so long. So I have funding attention deficit syndrome. Once the funding is gone and the scientists are gone and the partners are gone, who is left? And it's you all. It's the people that live in the community. It's the citizen scientists. So what's happening now, particularly with Living Shorelines, is money's going out and scientists are working on it and everybody's all over the marsh and everybody needs a boat and everybody needs waders and there's equipment needs. But these funding commitments are for 2 or 3 years. So who's going to be left once those funding commitments are over? And that's really where we know we have to build a citizen scientist corps. I really wanted to touch base quickly too on the National Water Monitoring Council because there's a wealth of information in here. So this is just to expose you to this, and then you could Google and mine it on your own. The National Water Quality Monitoring Council, this is the reporting structure. It basically came from the top down, from the Secretary of Interior down. And that's the reporting structure. With the idea is that we need to collaborate and coordinate and communicate at a national level to figure out strategies for improving water quality and assessments. Here are the tools for you as folks within the community. There's newsletters, there's free webinars, there's information about new sensors out there, the water quality portal, which we'll be touching on later today. Encourage you, our 4 citizen scientist groups that collected information, to consider putting in an article and giving us a photo, and give some kudos to your volunteers in all of your effort. Let's get your good word out there and get you in the newsletter. And there is a focus on volunteer monitoring and tribal monitoring at the National Water Quality Monitoring Council, and specifically within the newsletter. We now have a YouTube webinar, or YouTube channel set up, and we just had a webinar on continuous monitoring of nutrients, which was really interesting. And the portal
This portal is designed to capture data from EPA and U.S. Geological Survey and now the USDA Agricultural Research Services. And it's a user-friendly web-based interactive tool that allows you to find water quality data. This is just in one little snippet of the lower Potomac River, 161 USGS sites and 169 EPA sites. This comes out of the water quality portal. There's a lot of data going on. There's a lot of data collection. And at the national level, I wanted to mention again, there is a great deal of support for volunteer monitoring. I happen to chair the volunteer monitoring seats at the National Water Quality Monitoring Council. So we are always given time to talk about volunteer monitoring at the national level. Oh, map is terrible on this, but all these little points here, this is an inventory of all the volunteer monitoring programs and the sub-programs. So that might be a volunteer monitoring program, a program within, for example, around the nation. So there's a way to get your program onto this map as well. But when you click on one of these, this is on the National Water Quality Monitoring Council's website. When you click on one of these points, the information about the organization and the contact will come up. So I want to leave you with this because you need to realize that you are not alone in what you're doing. There is a whole army of folks out there interested, participating citizens and volunteers that want to figure out what is going on with their water quality and how they can contribute to fixing it. And that's it. Thank you.
Okay. This one does what? That's all right. All right. So hi, everybody. My name is Sam Marquand. I'm the Environmental Job Skills Program Director. It's a mouthful, I know, at Rocking the Boat in the Bronx. For those of you who don't know, we are a youth development organization focusing on high school age local kids. We have two components, a boat building component and an on-water component. So I direct the program that works with the juniors and seniors, the older kids, and the on-water component, which is pretty much an environmental restoration focused program. So I'm going to get into a little bit of what our approach to citizen science is today. So our approach is actually pretty basic, with the exception that it's youth focused. So obviously I'm out there working with somewhere between 10 and 12 environmental job skills apprentices. These are kids who've come through our on-water programs, learned to row, and then we go out on the river in the boats that the boat builders and the other half of the program have made, and we work on all sorts of restoration projects. Obviously, we're looking to do projects that are grant funded. We need funding for supplies, for man hours, and all that kind of stuff. We're looking to build scientific partnerships. It's really, really important to us that the apprentices get to meet working scientists. So we're learning from them, we're being trained by them, and ultimately we're reporting our data to them. So that's why I wrote Work with a Purpose. We are not interested in doing work where we just collect a bunch of data and then sit on it. We really want to hand it off to somebody who needs it, who wants it, who's going to publish it, who's going to put it up somewhere and use it. So I'll give you a quick run through of some of the projects we've worked on this year. This is probably only about a third of the things that we've done, but I'll lead, of course, with this because it's topical. So we've been doing water quality monitoring on the river for 5+ years with the Bronx River Alliance, reporting all our data to them. And they've just made an awesome new website that displays a lot of that data going back quite a few years, which is very cool. Then we started doing pathogen monitoring thanks to HEP and EPA this past summer. And that was a really, really, really excellent new look at, I I guess, something we've never really done before. So the kids are learning something new. I'm learning something new. We get to go out there and collect some data that really matters. And we learned some really interesting stuff doing these projects. So we were reaffirmed in some of our previous beliefs going in. When it rains heavily, we're going to have CSO events. Our pathogen levels are probably going to spike. We learned new things like the illegal outfall pipe up at Muskrat Cove. So it was a really revealing and interesting project, and one we hope to find money to actually continue in the future. To give you some ideas of other things we've been doing, we have a number of green infrastructure projects that we've worked on. We have 2 rain gardens on site in Hunts Point. We also helped build this Water Wash ABC project along with an environmental artist named Lillian Ball. This is located behind ABC Carpet and Home in Hunts Point. They have a giant roof and a giant parking lot, and everything was just running off directly into the river. So we helped build and install this wetland that filters all the water from the roof and the parking lot before it goes into the river. And this is it sort of in its early stages, about three years ago. It looks really great now. We've done a lot of oyster growth and mortality monitoring along with New York, New Jersey Baykeeper, and now the program in the future, again, if we can find some money for it. So that's another thing we've been working on. This is one of our newer projects. It's been really, really cool. It's an American eel monitoring project. It's kind of hard to see, but there's a little glass eel right there. You can see the kind of like poppy seed eyes. So our kids were working with WCS scientists to build the eel mops, install the eel mops in the river. And these are sort of passive traps that we sample, we pull up, we shake them out, see if we've got any glass eels migrating into the river. Another really excellent, interesting project that yielded some really, really useful data. We've done a lot of nutrient bioextraction work in partnership with UConn and NOAA. On the left here, you can see the students installing mussels on a raft that's out in the mouth of the river. On the right here, these are a couple of my students with some sugar kelp seaweed. The objective here is to filter out nitrates and phosphates from the water using native species, basically. So the future of citizen science as we see it is we want to continue as many of the existing monitoring projects as possible. We try to build a lot of the projects, such as the water quality work that we do with the Alliance, into sort of what we call kitchen sink grants, where we can put a lot of our projects into one area. We want to ensure, of course, that the data is being used. Like I said, we're not interested in just doing stuff solely for educational purposes. We really want the kids to be working and collecting data more like a field work team and making sure that we're passing on data that's going to be used by somebody. And then, of course, pertinent to this talk in particular, we're really interested in expanding our water quality monitoring. I'm very interested in keeping the pathogen monitoring going. We've actually put in a grant to buy all of the equipment that the EPA lent us for this project. So we're hoping to buy our own so we can do this all the time. And then I'm also really interested in adding algal bloom monitoring. We have real issues on the Bronx River with algal blooms every summer. So I'm really interested in seeing if we can find some funding and some partners who are interested in doing that kind of work as well. I think that's it. Yep. Thank you.
Well, thanks everybody for a terrific panel. I think you really put sort of the discussion of the specific projects into that kind of broader agency and community perspective. I'm going to open it up for questions in a second. I do want to sort of take a prerogative of maybe asking each of you kind of the first question, maybe challenging you a little bit. And this is definitely in self-interest. You know, as you know, Gabriella and I and the rest of the HEP team and the along that spectrum of sort of volunteer activities to citizen science, you know, sort of, you know, trying to find our place in that world and how we can, you know, as a management conference that brings agencies and the community together, you know, what our special niche should be. And Obviously I love the funding attention deficit syndrome. And we're about to experience it, frankly. So, money is good. We all know that. Money for us, money for you, money for programs. So that I think goes without saying, and we don't want to sort of not pay attention to that. But how can we, assuming we had more money to give out, how could we frame that money? What else can we be doing if we're subject to that syndrome? So let me start with Venetia, and I'll put you on the spot first.
Thanks, Rob. It's a good question. I mean, I think as I was sort of stated in my remarks, I think HEP is sort of a natural convener and clearinghouse, and I think it would be great if, my dream is sort of everybody has the same standards, everybody has the same protocol, that is streamlined, like you're saying, from quality assurance, like what has the parameters that we're looking for in terms of, any laboratory requirements. So there's sort of just an understanding for any group that wants to engage in this, that sort of it would be great if there was just one place where all of this was uploaded, and maybe you DEP, you have your data, and I'm thinking we have some data, and EPA has data, but maybe across the estuary, your territory, you could serve as sort of like one clearinghouse where you could go and sort of find everything. I don't know, potentially. And then I think to be also the place to ask the questions of everybody here and everyone engaged in this is to what are we trying to solve for? I still think there's so many different potential questions to ask. And what is it? I know I heard very clearly from many people that you want the data to be relevant, you want the agencies to use it, you want to be taken seriously, and I think I agree that's essential. But what are you solving for? Do you know what I mean? Like, what do you want out of this? So that there's sort of a common consensus for what we're trying to achieve collectively.
Yeah. Anybody else wants to take that on?
I'll just say from our perspective, I think you hit the nail on the head. I think that although our feedback was just for two things on funding opportunities, which, as we all know, funding is hard to come by, and taking our data seriously, you're absolutely right. It is the community's data, and where do they want to take it from there? You can bring it back to the community, and they're aware of what's going on in the community, but what is the next level? And I think we've heard that from all four people here. I think they've heard it from us as regulators, and I really don't know what the next steps are, because I don't know where we want to take it. Do we want to have this one big giant database in the sky that somebody's going to run and somebody's going to maintain, and who's going to do that? Going back to money, resources, even bodies who's available to do this. It seems like a cliche for regulators to kind of spout off the same thing all the time, but it is true. I think that the next steps would just be to kind of move in the direction we're going. I mean, I kind of like where we're going. I want to help, or I shouldn't say me personally, but the region too, or how we look at it and how our part of EPA looks at it, is that we really want to help the communities. We want to give the communities what they need to get the data that they want. I know at the flip side, there's other sides of citizen science who would look at, well, what can the citizen and community groups give to us as researchers? So there's really two sides of that, and I think that shall the twain meet? Perhaps. I don't know. But I think that we saw so much in so many areas in disparate communities that, they do need our help. They need to have the tools to get themselves going. There's so many sophisticated organizations out there that have the ability and have the money to be able to do the sampling. And there's some that are a one-person, two-person operation. They don't even know where to get started. So that was one of the items that we spoke about at our workshop, is how to get a citizen science started, a program started. So I think that helps. And I know that really doesn't answer the question, but I think it's kind of covering like a cross section of everything that's kind of rolled into one. And there's a lot of answers that we need.
Well, obviously I was going to say funding, but you told me I couldn't. Well, can't stress it enough. For us, I think it's, as I sort of concluded on my last slide, there's plenty more that we want to do. We have a lot of ideas of things we'd like to learn more about on the river, and it's sort of for us. It's how do we get those opportunities? How do we meet the right people? Who wants the data? That kind of stuff. So that's the kind of support I would love to see, is being connected with working scientists who are willing to put us to work. I mean, that's what we're looking to do.
So I think first and foremost, the forum for sharing and a forum like this is really important, because I don't really feel like we get a lot of opportunities to network and share at this level. And then I will say this with a little bit of caution. Maybe this is on a personal note of maybe not necessarily representing the agency, but I realized that successful programs can't be all things to all people. So it really takes focusing in on what you want your goals to be, and then staying true to those goals, but sharing your ideas and sharing your lessons learned with everybody is really critical. So, that's pretty much it. Define your goals and work towards those goals, and continue allowing us the opportunities to share and network for our community.
Oh, yeah, that's great. Just maybe just to add one other thought on funding, and I don't know that this is necessarily a role for HEP, but I think that, like what I mentioned before about this, the Citizen Statewide Lake Assessment Program being in the environmental conservation law is very powerful. That because, as you say, funding comes and goes, but if something is mandated that it has to happen, then that's powerful. And I think also, and we've spoken about this, those are potential funds that should be, I think, reinvested in the communities where those impacts happened. And I think monitoring and ongoing monitoring is a very legitimate use of those funds, and something I think we need to kind of collectively explore. Again, looking at ways to kind of get consistent funding that is not sort of going to be rated every other crisis.
All good. Let me open it up to the floor. I know on this question or any other question that folks have, and I'll move around.
Yeah, thank you. My name is Robert Tompkins. I'm with the Sparkill Creek Watershed Alliance, and I want to focus on exactly what this topic is. We're a group of people. We're not affiliated with a university or any institution. We have our theories. We have actually some scientists that are in the group. Would it be helpful, at least I think so, to have the role of the state or maybe the EPA take on a consulting role with the various citizen scientist groups to periodically do an assessment of what we think the problems are and approaches. The consultant knows the regulatory requirements to guide us to gather the data. So do you think that could be a role or something like that? Maybe coming from the regulatory departments.
Again, I mean, to answer that question, I think absolutely yes, there is a role for the state. And in this, again, I keep hearkening back to this lake assessment program. The coordinator, DEC is also required to analyze the data that comes in and produce an annual report in consultation with the citizen scientists, basically. And the coordinator facilitates that exchange. So there's a definite model, and I think so it can be done. And to your question, I think it should be done, absolutely.
And just to, there are many requirements as far as like Clean Water Act requirements and other requirements where public participation is required by law in different aspects. So I would also encourage you to be the informed public when it comes time for a new rule to come up, or when it comes time for a rule change or an amendment, that you as the informed public within your community take the time to actually comment on that stuff. And that's also where you become the informed public that can provide good feedback to us as an agency.
Let me go back here.
Hi, thank you very much. My name's Carrie. I'm from Hudson River Park. And I'm really interested in how you guys are sharing data with different agencies. But ultimately, I often feel like we're only getting data to people that are already interested, voters and people that are already part of this wonderful choir that we have. So I'm interested in how we can collectively work together to increase visibility of this great data and our findings with people that are outside of the choir. And if we can have a form or something like a grading system that potentially does simplify, but also does allow more people to at least be tuned in to the health of our waters and to them recreating and using our waterfront areas.
Yeah, I mean, I think that's a terrific idea. I don't know if any of the panelists want to sort of have some thoughts on that in terms of engaging the broader public. Is that possible?
Yeah, we could. That way you don't have to give it up.
We're going to get to the back of the
Well, we've tried to do that with sort of limited success, I would say. So, we've been collecting data on the Bronx River for a long time, and we have a population of people who live nearby in Hunts Point who love to fish and loves to swim, and I know that those things are bad ideas. And the question is, how do you convince them that they're bad ideas? And it's very difficult. So we've tried different things. We've tried just sort of public outreach with the program. We go out with the kids and we talk to people about what they're doing and whatever. And we've tried flags, on bad days when the water quality is really terrible, put up a red flag, do not swim. It's really, really difficult in our experience. I'm not sure that we've sort of hit on the right channel for how to transmit that information yet. We also have a whole bunch of language barriers in that neighborhood as well. To everybody who comes through about these kinds of things. So yes, we're going to take you out on the river and we're going to show you that it can be a great time, but we're also going to tell you why you shouldn't swim in it. So hopefully we're getting our point across person by person. In terms of widespread dissemination, we've had trouble with that. So
Taking people to the river, to the resource, to the wetland is key, right? And that is really where your messaging and the messaging, that environmental messaging, really needs to be able to build people's confidence so that they can then communicate your messaging around their dinner table within their community. So as a scientific-minded person, it's very easy for me to rest my laurels on my acronyms and my large words and my scientific data. But I like to use the analogy of, I'm not a tax accountant. I don't do taxes for a living, but I turn my tax paperwork over to my accountant, and I hope that she does my taxes well. And I don't really ask her about the logistics of how she did it. I just ask her 2 questions. Do I owe money, or am I getting money back? And I would say that us as a scientific community or the informed public, we really need to consider what the questions are within our community and then answer those questions and engage people. But I think you get so much more done when you're at the banks of the river.
Hi, Rob Buchanan from the New York City Water Trail Association. I want to say, there's this question, what do we want to have done with our data and what do we want our government agencies to do with it? One thing, this is a suggestion that we've made a lot, is you could look at the models of the way we display our data and you could use it yourselves. You guys have the most, when I say you guys, I mean government agencies in general have the most data and it's the most inaccessible. The public can't get to it. So if it were conveyed in a way that was understandable, that would be a huge step. So that's one way, it's not our data, but the form of expression of our data, that could be used as a model. And I hope that happens. And the other thing I wanted to clear up here is a lot of our programs, particularly if we're talking about CSOs and sewage, are dependent on this EDEX technology, the kit. Kit's really simple and approachable. And so I thought I heard you say earlier that you were having trouble getting those results accepted on the basis of the fact that you're using that kit. And I really hope that's not true. And I just wanted to try and put the New Jersey DEP person on the spot and say, I hope that isn't actually the case, that you're saying to this group or any group, can't use that kit, we don't trust those results. I mean, the whole citizen science thing in CSOs really, at this point anyway, until there's something else that comes along, really depends on that being the standard.
Is that a comment or a question? Okay, so the question piece of it would be that we have some very thoughtful scientists at the agency that have done replicate samples and split samples and have worked with the actual manufacturers of IDEX. And through their personal experience, we realized that there are some flaws in the IDEX as it relates to saline waters. And that has also been their experience. We heard a little bit about the fact that, the IDEX and the actual method that's approved by EPA were running differently, and the IDEX was showing lower results than the one or the other. So it is a good indicator, but we can't embrace science unless it is true. But, and it's not just a personal thing. It was actually went to the manufacturer, and we could put you in contact with that person. That's not a problem. But there are methods that are approved that are very easy to do as well. And, so that's what we really are honing in on, and hopefully honing in on for our year 2 project.
Hi there. Thank you guys for a second. It's really incredible work that everybody's doing. And I'm just curious if this community is all consulting with other cities about how they're doing this, and finding best practices in our country and then outside of it, and as well as just to inform everybody here that every year there's a trip that goes down the Hudson with the Haudenosaunee Confederacy. One opportunity for there to be like consistent consultation about how we collect data on our waterways, because people come out for the tour. So yeah, is there a consultation with other cities across the world and nationally for best practices and that working with natives?
There may be, again, I'm speaking for DEC, there may be other people in our Division of Water that could answer that question. I would think so, I would assume so, I just don't know. I can't speak to it, but it's a good question and I'll take it back.
And I think on the EPA end, at least in Region 2, I would defer to the same thing. Our water people, our program office, that's not what we are. We're the scientists down in Edison. There's other scientists and engineers up here in the program office. So if anyone is here that could comment on that, I would appreciate it from the EPA side. Actually, Joan just left, so unfortunately, she's a branch chief, so.
I know when the Sewage Right to Know Act passed that was definitely based on the experience in other places, that it drew upon that. So I would think the answer is yes, I just am uninformed.
Hi, my name is Marissa Altman. I'm a conservation intern with the National Parks Conservation Association, also a research student at the Smithsonian Institution Division of Mammals, and I have an interdisciplinary background. I liked your kind of question about, well, what would this look like in terms of data sharing? Would it be just a big database in the sky? Who would access that? Who would manage it? And I actually developed, well, it's developed, but I'm inputting data for a wildlife management database for Jamaica Bay that basically pulls data from a wide variety of sources, including government reports, published peer-reviewed data, as well as citizen science data and natural history collections information. And with, I think maybe, and this also goes back to the comment from the Nature Conservancy, I would also recommend maybe looking at citizen science for wildlife as well. In terms of standards, obviously it's very different. Exactly the same, put that all into a resource that's usable in some way. And I also realized that the work that's been done here is fantastic and amazing, and I'm really impressed and inspired. But I'm sure that there are other groups that are smaller that may not have the access to this forum and to the resources and the funding and even just the logistical support. So again, I would just, well, I would say first, I think a database, like, it is feasible. I mean, it took me about a month and a half to kind of design the relationships needed to do that. And then in terms of hosting, like, we don't have a bunch of resources, so I'm sure somebody else could do that. And then also just to, again, recommend looking at the work that's been done for wildlife and using comparative methods and engaging citizen scientists in that as well. So I guess it's more a suggestion and support.
Is that database public that you're working on now, or when do you expect it will launch?
Hey. Within like our agency, but I think it's a really useful tool, and like I based it on relational databases that the Smithsonian uses to manage natural history collections. So I'd love to talk about it with anybody and hopefully help, because I'm all about science-based decision making. Like that's what I'm doing with my entire career as well. So I would love to maybe talk about that perspective and like how you can use that. And another suggestion is like eBird and iNaturalist are being used for wildlife data, and eBird actually has like, you can request like the data, the whole data set, or like the vetted approved data set, and there have been peer-reviewed publications based on that data. So, you know, it's not perfect. We can exchange information with anybody interested in that. I'd love to talk to you about it.
Area of Brooklyn, New York. I am an example of a one-woman project that started with just me, myself, and I. And I thank God that the door of opportunity opened for me to uncover the possibility of ecological problems in my area. I was able to connect and collaborate with Hunter College Science Department, their graduate division, and they worked with me on developing proposals. And now I am working with Medgar Evers College. So it is success from one individual, recognizing that there is a need, and you will get help. And I also, the question I'm asking is to bring it home a little personal. I have witnessed, well, two things. Through the research, we have discovered polychlorinated biphenyl presence in my community, and to God be the glory for that. Now I have on my property a lot of snails and mushrooms. So I'm trying to understand, as I've listened to the presentations about pathogens specifically related to water, how is it possible and what can we do? Or what information can you supply us to help us further our research endeavor? Thank you.
I just have at DEC in terms of especially working with community gardeners, but trying to think about how to have standards for soil testing. And Cornell Cooperative Extension has also been working on this for some time. But you bring up a really excellent point, and it's another, you know, all the benefits that we've been talking about, engaging people here and understanding the connections between science and their lives and their health and the environment. I think you're spot on the land-based side as well.
Good afternoon. My name is Stan Stephenson, and I just wanted to comment on the part of the data and the database and so forth. So at 1:30 this afternoon, the groups, I'm going to hold a training session on submitting the data into the EPA's water quality exchange system. And hopefully this will make the data available to regulators during their normal course of business and so forth. So if anyone has questions about how to do that or wants to come down to the 23rd floor at 1:30, welcome to attend.
I think we have time for one more question. I'm going to go over here and we'll have to wrap up.
Thank you. I'm Meiyan Wu. I'm from Montclair State University. First, I would like to say that I'm with the Friends of Bonzo Preserve project. And this project, I believe that is a good collaboration between academia and a volunteer group. I would really like to encourage any of the volunteer monitoring group to reach out to the academia partner to asking for support, both equipment and technical support. And I believe that many of my academic colleagues will be willing to help out in any way they can. But the other comment I have is really for organizers or funders. Throughout this program, we talk about how to do monitoring a lot. One thing that I feel that we haven't really spent much time is the waste management, particularly for pathogen. The waste management part has not really been discussed much or provided. I would encourage that we talk about that to properly manage the waste, particularly for pathogen testing. The biohazard waste could be a potential concern. Thank you.
Yeah, okay. So, well, listen, we've reached the kind of witching hour of 12:30 or a little bit past. I want to again thank our terrific panelists and all the and Gabriella has one final comment for everybody.
So don't forget to, if you're involved in citizen science, to fill out, or if you're interested in starting, fill out the questionnaire or make sure that we have your contact information. Check out the sign-up sheet if you didn't. If you're not listed there, please write down your name and email, and we'll be sure to get